Good morning, good afternoon, good evening, depending on where you are. Because when I was seeing registration, I saw some people coming from US, some people registering from other countries across Africa and Canada as well. So you are all welcome. It is a great pleasure for me to welcome you to our first webinar of the year. My name's Grace Ingabire. I'm the CEO of Rpki. Rpki is a not-for-profit organization representing the interest of the internet community. We manage some services like the Rwanda country code top-level domain and the internet exchange point of Rwanda, which is known as RINEX. So I would like to start thanking everyone who has made it today. We are truly honored to see participants across Africa. And I said earlier on, we have seen people from US and Canada. Earlier on, we had planned this webinar to be meant for the local community, that is the Rwandan community. But later on, we thought that it will be good we open it up for other countries to join, because we believe this is something that they would wish as well to learn. So I take this opportunity to thank the management of Afrinic for availing our today's speaker. And I think when I'm just seeing Eddie, the CEO of Afrinic, joining the call as well. So we'll take a few minutes, we'll give him a few minutes to talk before we start our webinar today. So the topic is on resource public key infrastructure, which is a service that provides security for internet routing. It is a security layer in BGP routing that provides full cryptographic trust towards ownership, where the owners have a publicly available identifier. So Rpki makes BGP more secure and reliable. By using Rpki, legitimate holders of number resources are able to control the operation of internet routing protocols to prevent route hijacking and other attacks. So our guest today is Stephen Musa Onlue. I don't know if I pronounce it well.
Yeah, sure.
He's the project manager and transformation lead at Afrinic. He holds a master's degrees in IT and currently pursuing an MBA. For the past 15 years, he has contributing to and serving the internet community in Africa and across the ecosystem. But before we kick off and welcoming our guest of today, I would wish to give a few minutes for the CEO of Afrinic, just for his welcoming notes. So you are welcome, Eddie.
Hello, ndabaramukije. Nkuko mubibona njyewe nambaye by'iwacu. But this is an official meeting, and it's not by it's by accident that I have a Rwanda t-shirt today. Today I could not go to the office because in the morning I just learned that my son has COVID, so I have to do work from home, and this is the reality of these days. And but it is mild because he already got his first COVID turn when we're in Rwanda. It's an honor for us to be with you, to have this time with us. And I'd like to thank you. I was not aware that this is happening, and I like the fact that Grace and Stefan finally get this going. And I just come from a tour in West Africa, in Benin and Cote d'Ivoire. And when we were there, we spoke a lot about Rpki. And, you know, there are times I think in this fourth industrial revolution, there are things that don't require a lot of investment. If you want to send a rocket to the moon, it requires certain investment. If you want to do to build up a car and so on, it requires a certain investment. But ensuring that our routes are secured, our network are secured, is our responsibility, and it's not that difficult. And Rpk, as Stefan will tell you, is ready to accompany you to implement it. So we really want to go from this type of session towards ensuring that that all our neighborhoods are done. And one of the examples that I used when I was in West Africa is exactly what happened in Rwanda, about Muganda. You have to give Muganda. When we go in Muganda, sometimes they tell us just clean up in front of your compound, right? So sometimes when so if all of us clean up in front of our compound, eventually the entire neighborhood is clean. Right? So Rpki is the same. It is something that's, for it to work, for it to be safe, for it to weight something, we need as a community to implement these type of things. And we're also looking for model countries that show that these things are possible. We have signed already an MOU with Benin and to do these type of things. We discussed also in Ivory Coast. Benin was signed, I think, last year. But I do believe that with an MOU or not, if the people around this table decide to do it, it can become a reality. So I really call upon you to not only listen, but also implement. And then we have a cleaner neighborhood all over Africa, because these things are technologies that are there, but when you look at Africa, even IPv6 and so on, you see that Africa is still behind. And yet these are not technologies that are that complex for us to implement. I'll pause here and let the real meat be served. For me, it was just entree. And let Stefan or Grace continue. Rakos.
Okay, so thank you so much, Rakoze cyane Eddie, for joining us today. So we are going to start our meeting, but probably one last thing that I would like to mention is that there is a feedback form that we'll share when we take a break, and would wish all of you guys to fill it. Turifuza ko mwayuzuza for us to know exactly what you would wish us to bring in as the next content for the next webinar. So once we send it, please feel free. It's just 2 minutes, and then you just submit it. Bizadufasha to organize more session in our upcoming webinar. So Musa from Afrinic, you're welcome.
Yeah, sure. Thank you, Grace. Thank you, Eddie, for the introduction. Welcome, everyone. Today we are going to discuss about Rpki, which is the resource public key infrastructure. So our agenda will be something like this. We are going to look at what is the problem, and we propose several solutions, and at the end we decide which solution is more accurate for us today. So yeah, so what's the problem? I'll start by painting the picture of how I see the internet in Rwanda today. Sorry if we are focused in Rwanda, but this is basically the same, almost the same situation in most African economies. So we will start by looking at the status of the number resources in Rwanda. So with regards to number resources in Rwanda, right now we have 6/32 IPv6 prefixes. We have 21 autonomous system numbers in Rwanda, and we have 1000/24 IPv4 prefixes for a total of 15 registered members. So in Rwanda, 15 organizations have their resources from Afrinic. And right now, when we do a statistics, because the population of Rwanda right now is 13 million, 13.5 million, when we do a statistic of the usage of IPv4 in the country, it's basically 30,167 IP persons, that is people using a single IP. That's a lot of nuts in the country. I'll keep that conversation for another day. Nuts in Rwanda. we can discuss about that. So how does the world see Rwanda today? So as I said, we have 1083/24 prefixes, but out of these 1,000 prefixes, only 266, and these are the aggregated prefixes, 266 prefixes are visible on the internet. 266 prefixes, 18 ASNs, and the ratio on prefix versus ASN is like 14 prefixes for each ASN. For IPv6, I said we have 6/32s. Only 3 are visible on the internet right now, with one autonomous system number. With 3 autonomous system number, that is at least 1 prefix for each autonomous system number. Now, how are we doing RPKI wise in Rwanda? Currently, we are at 4.76%. How would I say, adoption rate in Rwanda. You can see Africa, as I was telling you, is quite very red. And our goal here is to make this internet secure for everyone. In terms of other best practices, security best practices in Rwanda, what we see here is, if you look at, like I'm displaying here, 4 best practices. Filtering, we are doing quite well. We have like a 99% filters that are applied in Rwanda. Anti-spoofing, we are blank. We are blank, and coordination, we are at 100%. It means that like Rwanda networks are, documenting their networks well in the global platforms. With regards to global validation, so global validation has 2 components: the IRR, that is Internet Routing Registry, and the RPKI. For the IRR, we are at 75%, which is not too bad, but we can get that at 100%. We can get totally green in terms of IRR. And in terms of RPKI, which is the beast today, we are at 9%. So we saw 4% there and 9% here. So it's a matter of, data interpretation, but you see, we are not really far. So there is still a lot to do. Still, in terms of these statistics in the country, if we are looking at the RUAs in the country right now in Rwanda, this is what we have: a lot of unknown. That is, I will explain what are unknowns in few minutes. If we look at some specific ASN, like ASN 37124, that is Tigo in Rwanda, they're having a total of 14 prefixes. None of them is having a valid ROA. All of them are unknown, so they are not yet in the business of RPKI. But there are actually some good players in Rwanda, like Canalbox. Canalbox is having 29 prefixes, and all of these 29 IPv4 prefixes have valid ROAs. They're having 13 IPv6 prefixes that are announced. All of them are covered by valid ROAs. So we have at least some good players. We have like 3 networks in Rwanda out of the 15 that we named that are doing well in terms of, documenting their network, doing IRR and RPKI. Now, from the stats tools, this is the global validation, like globally. On IPv4, right now, we are having 34% of prefixes that are covered by valid ROAs. The rest, that is 1%, is invalid, and the rest is unknown. So there are like 65% of networks out there that are not yet doing RPKI, which is not a good figure. We are yet to, this technology is here for a while now, and it's very well mature, and we are encouraging network operators to adopt this to avoid the problem that we will name in few slides ahead. So routing incidents are causing real-world problems. They're causing real-world problems. And if you look at the internet security concerns, this is an old graph, but it's almost the same today. You will see that traffic hijacking costs for 74% of incidents on the internet, security concerns on the internet. It is followed by DDoS attacks and IP address spoofing, and then you will have host availability, blacklisting. So, but you see at the top of the list here, we have traffic hijacking, which is something that is very well linked to the topic that we are going to talk about today. So, what are the routing incidents? We have two main routing incidents. We have prefix hijacked, we have route leaks, and then now we have IP address spoofing, which is not directly linked to routing, but which is also a concern which we are proposing a solution for. So what is a route hijack? A route hijack is a situation whereby someone else on the internet, an organization, a TS organization, decides to originate a prefix that does not belong to them. So if you're having your prefix, let's say you came to Afrinic gave you a prefix like 192.0.2.0/24, and a prefix like 2001 DB8::/32, and you are originating this prefix. While you are announcing this prefix, other peers on the internet will propagate that prefix, and your customers will be able to reach your services. But just imagine at a point in time, someone on the internet, by mistake or intentionally, decides to originate the same prefix. What is going to happen? People will start believing on the internet that your services are located in a different location. So an example of this happens in 2008, whereby Pakistan Telecom decided to block YouTube in the country because there was an unwanted video on YouTube, and they wanted that video not to be accessible in the country. So what they did is they went ahead and originated the prefix of YouTube. When they did that, the rest of the world started believing that YouTube had delocalized the servers to Pakistan, and a lot of traffic started going there. The site of YouTube went down. So you see, by having this incident on the internet, your services might be unavailable for a while. So while we are speaking right now, there are a lot of these incidents happening on the internet. If you go on a website like bgpstream.com, you will see right now incidents that are happening on the live. Let me just see if I can share the BGP stream. So if I share bgpstream.com, so BGP stream uses BGP Mon to monitor the internet, the global internet routing table. We know exactly who is authorized to originate what prefix, and at a certain point of time, if we see that this has changed, then that could be a possible route leak or a possible route hijack. So now that right now that I'm speaking, you can see there is an outage. This outage happens from 12:33 UTC to 12:37. There is this possible hijack, that is Datation France. It has been detected. It was detected since 10 a.m., 10:52:26, and it's currently ongoing. There is this other possible BGP hijack, and so on and so forth. So these incidents are incidents that are happening on a daily basis. They're happening live. They're happening every moment, every single moment on the internet. So that was an example. This is an example of BGP hijack, whereby someone, so BGP hijack can happen on a more specific prefix or on the exact prefix. So this is a BGP hijack that happened on the prefix 103.109.211.0/24, which is normally supposed to be announced by HDF security, but beginning 11/9/2021, it was advertised, the same prefix was announced by ASN 6453, and it was detected by 27 BGP Mon peers. So that's the first incident that we can have, the first type of incident, that's BGP hijack. The second type of incident that we can have is called BGP leak. So if you look at the graphic on the screen here, you have AS 64500 is having two customers. So it's having two customers and is receiving prefix 8.8.8.0/24 from Google, which is propagating to the two customers. So at a point in time, the customers know that to go to Google, you need to go through that ASN, and the ASN, their ASN, which is the upstream provider, will direct them to Google. At a point in time, for some reason, AS64501, which is one of the customers, receives the same route receives a route from another transit provider to Google and decides to propagate that route to their upstream provider, which believes that, all right, if I have this customer which is propagating this route to me, it means that it's a better route. So it is going to be propagated to all their customers. And what is going to happen here is that to go to Google, all the customers of 64500 are going to go through 64501, which is very detrimental for their network because they are paying bandwidth and they are now becoming transit provider to their upstream provider. So an example is in June 2019, where Allegheny leaks like a very huge bond of prefixes to their customers very soon, and this caused a lot of traffic going through their network. So I have the link there. You can read through and have the entire version of the picture. So this is an example of route leak that happened. This was last year, and it was with Global Communications, who leaked 167,000 routes, and it was affecting 9,000, almost 10,000 ASNs in 193 countries. And so you see, this can happen intentionally or just a mistake in configuration. So this is an example of route leak again on BGP Stream, the website I just shared with you. You can go and check, and you'll see a lot of these things happening. These are some examples of route leaks that were happening when I was creating this slide in November last year. So these are incidents that are happening out there. They are not tales that we are coming to share with you. So what are solutions that we are proposing? We have a lot of solutions. We have prefix and AS path filtering. We have the Rpki, which is what I'm going to be sharing with you today. We have the IRR. You have tools like IRR toolsets, IRR PT, IRR BGP Cure 3 and BGP Cure 4. And then you have some standards that are not yet well adopted by vendors like the BGP Sec and many others. So the solution, there is one solution, there is a solution guide that is documented by ISOC, which is called Manners, mutually agreed norms for routing security. The mutually agreed norm for routing security is actually a set of actions that are defined by the ISOC for various types of networks. You will have like this program for, network operators, internet exchange points, CDN providers, and vendors, network equipment vendors. So this solution, as I said, is a set of actions that are documented by ISOC. It's a set of best practices that are recommended to network operators to make sure that we stop propagating wrong routing information on the internet. So as I said, we have 4 programs: network operators, internet exchange point, content delivery providers, and cloud providers, network equipment vendors. So for the network operators, this is the first program that was created under manners, and we have 4 actions. We have the filtering. That is, it is always recommended that when you configure your network, you apply filters. Filter everything that you get in, filter everything that you share with your peers. The second action is anti-spoofing. Anti-spoofing is recommendation to block every traffic that is coming into your network and that is originated by a spoofed IP address. And then we have the third action, which is global coordination, which is actually you documenting your information. That is information about your network, information about your organization, information about contacts in your organization on websites like your website, the peering DB, the internet routing registry. And the last action, which is one of the most critical, which is what we advocate for right now, is the global validation, which is where you use the internet routing registry and the Rpki to document your routing policy. There is actually a language called the RPSL, routing policy specification language, that is used in the IRR to document your routing policy. Is actually you telling how your information is being circulated on the internet. What are the peers? What are the networks that you are peering with? What prefaces you are advertising to these peers? What prefaces you are receiving from these peers? What are their ASNs? What is your ASN? What is your customer con? That is the list of the ASN of your customers that you are also carrying forward. So when you document this information in the IRR, other networks are going to look at this information to decide what prefaces are authorized to be originated by your ASN, who is entitled to originate a prefix that belongs to you, and so on and so forth. So this information is very, very critical for the routing, for the global routing table. So now I just briefly discussed some solutions, and if you noticed, I put an emphasis on the IRR. The IRR, Internet Routing Registry, is a set of databases that are globally distributed. So some of the IRR, like Afrinic, we have the WHOIS database, whereby you can create your route and your route 6 objects to tell the world this prefix can be originated by this ASN. But the problem now that we have with the IRR is that there are third-party vendors like EntityCom, RADDB. These databases, sometimes they have information that are not accurate. Like right now, if you come to Afrinic and we give you a prefix, like you can create your route object and your route 6 objects. When you leave, when that prefix is revoked from you, those objects are going to be deleted from the database. But when you create proxy objects in those third-party vendors like the RADDB, when the prefix ceases to belong to you, those objects are still there. So this is why there is a lot of inconsistent information in the IRR. So recommendation now is to use the RPKI. So what is RPKI? RPKI stands for Resource Public Key Infrastructure. So you already know that one of the components of this infrastructure, the public key infrastructure. The public key infrastructure is a system of public-private key where we use certificates to sign objects like an email that you are sending to, let's say, a correspondent. If you want that email to, if you want the receiver to make sure that this email, to note that this email is coming from you, you can sign that email using your private key. And when it gets to the destination, they can now decipher and know that, all right, this email is coming from you. That email can have your signature. So the public key infrastructure has been there, and we have been using it in banking, in email exchange, document exchange, and so on and so forth. Now, we've decided to use the same infrastructure to secure the internet number resources. That is where we are having this resource public key infrastructure. So the resource public key infrastructure is actually two components: the resources that we want to secure and the public key infrastructure. So it provides a secure framework that is used to verify that a specific prefix is authorized to be originated by a specific ASN. So we are going to see how that works. So what can we do with the RPKI? The RPKI will state who is a legitimate owner of a specific IP block, and it will give authorization to a specific ASN to be able to originate that prefix. So there are two types of Rpk implementation. You have the hosted implementation, and then you have the delegated implementation. Right now in our region, Afrinic, we offered only the hosted implementation. The delegated implementation is the teams are working on that, and maybe sometime in the future we'll announce that to the community. So how does it work? There is actually a chain of trust, and the chain of trust is at the very top. We have a root certificate, we have a CA, and as you know, the resources are allocated to the various regional internet registry: Afrinic, ARIN, RIPE, NCC, EPINIC, LACNIC. And each of these internet routing, each of these registries have a self-signed certificate, which is the CA, the root certificate. So this is the root certificate, and it is self-signed. So now when we allocate a specific sub-block of prefixes to an organization, we issue a certificate, which is the LIR certificate, the LIR certificate. This LIR certificate is signed using the root certificate that we originated, the self-signed certificate. And this is the chain that we have. All right, so we have at the top of the chain, we have the certificate of the registry, that is Afrinic, is having a self-signed certificate. We now use this certificate to sign certificates which we give to the various organizations having prefixes at Afrinic. And this certificate that is generated for them is tied to their resources, the resources that we allocate to them. So Rpki has two actions: the signing of your resources and the validation of the resources. Right now, a lot of people are doing the signing and not the validation. As you can see, it's two separate actions. And these two separate actions they don't interfere. The signing is that part where you go on the portal of your regional internet registry and you decide to create what we call a ROA, Route Origin Authorization. That is you authorizing a specific ASN to be able to originate your prefixes. And the second part is the validation. The validation is actually when you configure your network to use Rpki to verify the routing information that you are receiving from your peers. So as I mentioned earlier, we have two modes. The hosted mode, where we have our servers in our premises, and then we create the ROAs for the organizations. And we have the delegated mode, whereby an organization can decide to install a standalone infrastructure, Rpk infrastructure in their premises, and then they generate their own root certificate. They send to us and we validate. This mode is good for large organizations like the Amazons, the Googles, who have resources across many regions. Since they have resources across many regions, it's not easy for them to go on the Afrinic portal and create their ROAs, to go on the Epinic portal and create their ROAs. So if they have their own standalone server, they can create their ROAs in their premises. And then now when validators are installed, I will explain what validators are later. When validators are installed, they can actually sync with their servers to download their TA with their various resources. So I mentioned earlier that we have two components to Rpki, two parts. That is the signing, that's the creation of the route origin authorization, the ROAs, and the validation. So what is a ROA? A ROA actually is a prefix with a prefix length, a max length, and an ASN that is authorized to originate this prefix. Then all of these are signed using the certificate that we issued for you. So this is an example of ROA here. We have this prefix 103.22900/23. It is actually a /23 network. But now we are going to create a ROA that is going to cover not only the /23, but also the aggregated prefixes, that is the /24s. That's why you see here the max length is /24. So this ROA is going to cover the /23 and the two /24s that are under this prefix. And this prefix, these three prefixes can be originated by ASN 10075. So what is a ROA again? It is a prefix, all right? It is an origin ASN and it is a max length, as I just presented earlier. So this is an example of a ROA, all right? This is an example of a ROA. This is actually a test that is ongoing with a research program at ISOC. So this is a ROA, and as you can see here, we have in this ROA two address family, IPv4 with the 103.138.2.100/24, and we have the IPv6 prefixes there. You have that /48 and the two /54s. And this is actually, as you can see, the ASID here is 0. So this is actually a test that is being done. But actually, if it was a real world, you will have a real ASN there, and that will be your ASN ID. So this is an example of ASN, of ROA. And what is a manifest? A manifest will give more detail, right? A manifest will give more detail about the ROA, as you can see here. And also in the ROA, we will have, this is actually the revocation list, a CRL, the revocation list. This is a list of ROAs that have been revoked. So these are components of ROAs. So now, remember I showed you a chain at the beginning, whereby you have the root certificate, and then you come to Afrinic, you get your resources, you get your certificates, which is tied to the root certificate. Now, where does the Rwa fit? You have that root certificate, you have your certificate that is being issued and signed by the certificate of the issuer, that is the internet routing registry, the registry, the regional registry. And then you will now use your certificate to sign your announcements on the internet. And your announcement is actually your IPv6, your IPv4, and the ASN that is authorized to originate these prefixes. And you bundle all of this and you sign using what we call, you sign using your certificate, and you have what we call a Rwa. Do we have any questions so far? If you have any question, please feel free to type in the chat. Feel free to, all right. We have Jonathan, your hand is raised. So go ahead.
Oh, thank you, Musa. That I was thinking to ask after the presentation, but let me just ask some that I was also asking myself regarding the BGP that you're saying in the first 5 slides, if I'm not mistaken. Do we actually use the SBGP, like the secure BGP? If not, what will be the requirement? Or is, if industries doesn't use them, like what is needed to be implemented? I don't know if my question is.
All right. So the BGP sec, which is still a standard, is not yet fully implemented. You know, when at IETF a standard is defined, there is need for implementation. The vendors need to implement it on the equipment before we can use it. Right now, the implementation is slow, so we are not yet using it. That is why what we recommend right now is IRR plus RPKI.
Oh, okay.
Is that okay?
Okay, I get. So the second one is about these keys that you are presenting, and I'm asking myself. Okay, I know that the technique cannot be like shared, how to encrypt and so on, but I'm asking myself, this kind of project, I don't know if it's running now or it should run in the future, and because attackers still can spoof, like can spoof themselves and try to attack. Still, this will not kind of secure our network, because that's our target. But I'm asking if this is implemented in other registries, like which kind of attacks do they still get the attacks now, or there's a big change in their project or in the implementation of keys, this PKI?
Okay, thank you. Good question. So as I presented here, the public key infrastructure is one of the most secure way of doing things on the internet. And as you know, it relies on a public and a private key, which is well secured, and is not easy to hack the public key infrastructure itself. Mm-hmm. So the system right now is being implemented, as I will present in next slide, is implemented on all the registries. All the registries have it implemented. Like right now, Afrinic is implementing it. Afrinic has it, it is running. You can secure your network using it. You just need to come to us and say, yeah, right now I'm having this prefix, I want to secure it, and we will support you, we'll help you and show you how to do it for your network.
Okay.
Okay. So what it avoids, you remember at the beginning, I presented that there are two routing incidents. There's the route hijack and the route leak.
Yes.
What is the route hijack, as I presented in the beginning, is someone pretending to be you. Like they take your resources, they originate using their ASN. The result of that is that people will believe that you are that person, and they will start sending traffic. They will start sending traffic. No, this is not, I'm not talking about spoofing actually. Spoofing is something else, right?
Okay.
I'm talking about the routing information. So if you have a prefix 192 196.192.0.0/16, that's your IPv4 prefix. All right. Let's say you decide to host in your network a web server with the IP 196.192.0.1/ let's say 24. That's the IP address of your web server. The way I get to that web server is by having the routing information that you decided to share. So you will actually configure BGP to advertise to the world that this prefix belongs to you.
Yes.
And all the traffic will come back to you. And because you have that web server in your organization, you will be able to serve us the content that's on that web server. Same for your mail server, same for your DNS server, same for every server, any resource that you are having in your premises. That is, you send the routing information, people propagate it to the world, and we can reach to your content. Now, just imagine for a moment, I decide I am a hacker on the internet. I decide to originate that same prefix. And I say to the world, this prefix belongs to me. And people start believing, Stephen is having this prefix. Let's go to his network to see web server 196.192.0.1. And when they come to me, I can save whatever content I want. I can steal their information. I can pretend to be you. I can scam your customers and things like that. So to avoid this, we have this resource public key information, right? This resource public key infrastructure, whereby you create authorization on the server saying, this is me and this is my prefix. Now, what will happen is when I want to originate, when I will originate this information and share on the internet, what people will do before they believe me, they will go and question that Afrinic server and ask, is this true? Since you already added the information on Afrinic, the Afrinic server will send back the right information and people will stop believing me. So that's how this infrastructure is used to stop inconsistent routing information from being propagated on the internet. Are we okay?
Okay. I was getting those points, but my question was like, still the attackers can get your public key, right?
No. Yeah, they can get your public key because public key is shared everywhere. Yeah.
Yes. And okay, I can share private. Okay, I see.
Okay.
I see.
Good.
Yeah.
All right. Jessica was having a question. Jessica.
Hello.
Yeah.
Hello.
Yes.
I have a question.
Okay.
So, for example, if you have your prefix in the Africa database, Afrinic database, so does Afrinic synchronizing its database with other registries? For example, or RIP?
Okay, interesting question. So actually, this database are standalone database. Remember I said that every regional registry is having their own self-signed certificate. So we went to IANA, and IANA gave us a block of IP addresses. We signed this block of IP addresses with our self-signed certificate. Now, when we issue blocks to give to our members in the region, we use this our self-signed certificate to sign those blocks. So we are standalone on the prefixes that we had from IANA. RIPE have their own certificate, they sign their own resources. ARIN has their own, and so on and so forth. So every registry is having their own certificate and they have signed their own resources. The way this is being synchronized is by using a piece of software, which I will share later. So we don't need to synchronize our servers. There is a way of synchronizing that. There is another piece of software, which is still part of the Rpki chain, which I will share later. Okay.
Because in some cases our prefix are not known on those databases. So that's why.
Are you talking about Rpki or a different database? Because if it's another database, let me know. Are you talking about the IRR database or you are talking about Rpki database?
IR.
All right. So IRR database, it is still a standalone database, but there is a way that the client that you are using does the synchronization. So if you come to Afrinic, for instance, and you query a specific prefix, let me even show you that. You can see my terminal, right?
Yes.
So if I want to query the WHOIS database, let's say I want to query the RIPE and CC server. What is your prefix? Hello?
Hello?
Yeah, what is your prefix?
197,
okay, let me just, pardon?
197, 243.
197.243. Oops.
Let's say the 0.0/17.
243.0.0/17. So look at, I'm querying what database? I'm querying the WHOIS from RIPE. All right. Let's see what information we get. So you see, it is giving me this prefix, okay, from IANA, and the role here, and this is the route object. This is a are you sure this prefix is at Afrinic?
Yes, of course.
Because look at what it says here. LACNIC, Latin America, blah, blah, blah. Did I type it right? 197.243.00.
Yes, /17, yes.
All right, maybe it's one of those prefixes you got and it was,
Maybe
did you get it?
We can take a /22 and see.
All right, let's check the /22. Yeah, so it's still at RIPE here. See, it's still at RIPE here. Let me check something else and show you. If I check 196.192.0.0/16, see what I get here. Oh yeah, I see what is the problem. So I needed to check directly from the source, that is Afrinic. it probably is my whois client. I'm not having the Afrinic whois client. So look at this one. Because I queried from Afrinic, it is returning the right information. So this is, so let me get back to that, your prefix, and I query directly from afrinic.net. So now what am I having? Yeah, now I'm having it. So when you query from a different source, like I was querying from Rpki, whois, it will give me the parent of that resource, trying to look which database it is. But if I'm not having a consistent client, it won't be able to get the right information. Reason being that these resources were allocated standalone to the organizations, to the various registries. Okay, a resource, a specific block that is allocated to Afrinic, all the information stays at Afrinic. Now, if other regions, they want information about a specific prefix that is at Afrinic, they will query the Afrinic whois in order to build their statistics and whatever information they want. Is that okay?
Okay, thank you.
All right. Okay. Thank you for the questions. So this is it. So now, when we get the Rpki components, we have the repository. All right, the repository, which is like the database where all the Rpki objects are stored. We have the Rpki engine, which is like we will say the front end, and then we have the portal. All right, the engine would be like the API, and then we have the portal. Like right now, this is at Afrinic, we have the portal which is called My Afrinic, the My Afrinic, and that is where you connect, and you can create your ROAs that are going to be stored on the Afrinic repository. So all the regional internet registries, they have their repositories. Afrinic has its repository, Epinic, Arin, LACNIC, RIPE. And in the middle of the chain, we have a software that is called the validator. Okay, this is the validator software in the middle, and then you have your network. Let's see how this works. So at the top, you have this repository where you store the various ROAs you created through the portal of the my.afrinic.net. You created your ROAs to say this prefix can be originated by this ASN, this prefix can be originated by this ASN, and so on and so forth. When you have that created, now all of these are stored on the various repositories. That is Afrinic repository, RIPE NCC repository, ARIN repository, and so on and so forth. There is now a software in the middle called the validator. The validator will synchronize with all of these repositories, download what we call the trust anchor with all the manifests, and then store it in form of what we call the validated cache. The validated cache. And then when you have now the validated cache, your router, your Cisco router, Juniper router, MikroTik router, will now synchronize with the validator and have, using the RTR protocol, and have that validated cache. When you have now that validated cache, based on that validated cache, your BGP is going to decide based on the policy that you are going to specify. So this is how it goes. At the very top, we have that RPKI, which is going to be queried by the validator. When the validator queries the repository, it gets two information. one of the two information, either valid or invalid. When it is invalid, you look at here, you have the route origin validation, the route origin authorization validation. So when you get, it is actually, it could be invalid or valid. When it is invalid, it goes to BGP as BGP as unknown. All right, and you can now decide on the unknown if you are going to validate or not. When it is valid from the Rpki system, it goes into BGP, and you can either have a valid state or an invalid state. A valid state is actually when the ASN matches the prefix and the prefix len match. When one of these is inconsistent, it becomes invalid. And what we are actually recommending right now is to drop all invalids, because those are possible hijacks. You can authorize valid, you should authorize valid, you can authorize unknown, because there are some networks that are not yet creating URLs, but the invalids, drop them. So this is an example of representation whereby you are creating a RUA for this prefix. The prefix is 193.0.24.0/21, and the ASN is 2121. Max len at this point, if you leave it blank, it means that it is going to be specific to that. So what you are going to get here is, this is going to be valid. All right, this 193.0.24 193.0.24.0/21 is going to be valid, but the sub prefixes are not going to be valid. All right, it is going to cover only this prefix. Another example would be if you decide to create this RUA 193.0.24.0/23 and you specify a max len here to be /24, it is going to cover this /23 and the various /24s. Okay. You have another examples. This example here, it is going to cover the /23, but the /24 are going to be invalid. Okay. So when you have this created on the Rpki engine, that is the first part. The second part now is to do the validation. To do the validation, you first need a validation software, right? A validation software that is going to query the various repositories, download all the manifest and have it there. Then now you will have the your router that you need to configure. So some example of softwares that you have, some examples of software are the NLab Routinator, Fault Validator, Octo Rpki, Rpki Client, Prova, and RP Steers. So I already presented the hosted model versus the delegated model. I have some videos here for you, for those who want to install the various validators in their network. You can install the Octo Rpki. The video is there on YouTube. You can install the Routinator, is there. You can install the Fault Validator. So when you've installed all of this, you can now configure in your network. For demo, how to create your ROAs on the Afrinic portal. This is actually how you do it. First step at the for Afrinic, you first need to activate your engine, your Rpki engine. And to activate this Rpki engine, you need to send an email to support service@afrinic.net. and they will get back to you with what we'll call a BPKI. When you get the BPKI, you can now use, you can either use the BPKI or you can activate the two-phase authentication. This is how you activate the two-phase authentication. You go on your profile, you enable the two-phase authentication. You are going to install a software on your phone for the Google Authenticator. And when you install that Google Authenticator, you will now, each time you connect to the MyAfnic portal, it is going to generate a one-time password for you to connect. This is still you enabling the two-phase authentication. Once the two-phase authentication is enabled, when you connect to the portal, this is what you have. You can now like list certificates, you can view your ROAs, you can view old ROAs, you can issue new ROAs, you can refresh the engine. So these are steps to create the ROA. First step, when you click on that create new ROA, you get this interface. On the first interface, you need to specify the ASN, you need to specify the prefix, you need to specify the max prefix length. So these are the steps. Here you will see that you've selected the ASN, you selected the prefix, you specify the max length, and then you validate. When you validate this, you need to also specify the date, the start date, and the end date for the ROA that you are creating. Once you've created this, you can list a row, you can list the ROA. Like this is an example of ROA. When you list it, this is the content. Like, is it revoked? No, that means it's still valid. It will not be valid before the 22nd of 9/2021 at this time. It will be valid until this date. This is the product URL. So if you type this URL in a browser, you will see the content of, just as I showed you earlier, the content of the ROA. That is what is the prefix, what is the ASN, and so on and so forth. So what makes a route origin validation invalid, right? So the max length, if the max length, you see when we're creating they ask you a max length. If the max length is less than what you are actually originating, it becomes invalid. If the origin ASN is different from the ASN that you provided when you were creating the ROA, it becomes invalid. All right. So it could be one of the reasons or both. So that is it for verification when the router receives your information. So this is an example of illustration whereby you created the ROA 2001 DB8/32 up to 48 with the ASN 65542. What is going to happen? Let's say someone decides to originate the route 2001 DB8 1234::/48 with ASN 65542. You see it matches here with the /48, which is covered by this ROA. So this route is going to be propagated. When it gets to this router, remember, it uses the validator to have the information. It is now going to verify if this route is valid, and is going to mark it valid. Now, someone else decides to originate, let's say the same prefix /48, but with the ASN 65536. When the information gets to this router, it is marked as invalid because it is the ASN here is different. Okay, so when you've done this, when you've created your ROAs and you've configured your routers, everything is okay. I'm going to show you how to configure routers, at least for Cisco and for Juniper. But before that, I have some videos here on how to create RWAs on the Epinic portal, Afrinic portal, Arin portal, LACNIC, and RIPE-NCC. Okay. So next now, all these parts that we've discussed is one part, that is creating the RWAs on the portal and maybe installing the software, the validator software. Now, how do you configure your router to actually use all this information that is in the repository to do your validation? First, you need to specify to your router what is the address of the validator. So here in this example on BGP, I've specified 2 servers. On the same server, actually, 2 validators are installed. One is listening at port 8323, and the other one is listening at port 3323. All right, refresh after 300 milliseconds. So this is how you configure the same configuration that I just did. Inform your router what is the IP address of the validator and what is the port number. Next, now you need to configure your routing policy on the server. So on the router, this is an example on a Cisco router, whereby I'm creating a route map with various validation levels. So at level 10 is a permit. The entry 10 is going to look at if the information that we receive is a valid. If it's a valid, the local preference here is set at 100. The second one, which is the second entry in the route map, if it is not found, the local preference is set at 80. The third one, if it is invalid, the local preference is set at 60. So you see, we go from the high preference, medium preference to a very low preference. So what is going to happen here? What is going to happen here is that routes that are valid are going to be preferred. Another scenario could be whereby if you have those invalids, drop them. Drop the invalids. So here we'll have valids are set to high preference, not found, because right now, as I told you, many organizations are not yet creating RWAs. So for these organizations, we are not yet dropping. And then for the invalids, drop systematically. Now, when you've created this route map, you need to apply it on your BGP sessions. So this is applying on the BGP session, router BGP 64.511, IPv4 address family, we apply it. IPv6 address family, we apply it on the neighbors. And when we apply this, any information that we receive from this neighbor will go through that route map that we created. Same configuration for Juniper. These slides are going to be shared. If you have like any other information that you need to ask, you have our contact, you can reach out to us. So this is configuration for Juniper. So at this point, I'm going to connect on a router on the internet, and we are going to issue some commands to see how these things work on the internet. So I'll bring in front again my terminal. Bringing in my terminal. Here, I'm going to connect to, if you go on route views, there are many of these open route collectors which you can use for verification. So username here is route views. Okay, so first thing here, I want to see what is the validator that this RPKI router is using. So I will do show IP, BGP, RPKI servers. So this router is listening to this server 184.171.101.187 at this port 3323. This is the port by default that is reserved for RPKI. So for RPKI validators. So you see, that is the validator. This is all the information with regards to this validator, to this specific validator. So we can see, do we have another validator on this equipment? So I can see right now. I can't see a second validator. So I see one validator. Now, so it means that this router is actually configured to listen to a specific validator. So now when it is listening to this validator is feeding the router with information that we are going to call the RPKI table. So how do we view the RPKI table? If I do show BGP IPv4 unicast RPKI table, here I'm going to see the information. So you saw that validation that I showed you, that the RPKI infrastructure validates information. It sends to the BGP router. The BGP router is now going to use this information to do the BGP validation. So this is the information here. You can see that there is this route, right? Max length is 24. It is authorized to be originated by this, and so on. This is the neighbor, and so on. So this is the information that you have. You can also do this for IPv6. So you can do the show BGP IPv6. Oops. IPv6 to view the IPv6 RPKI table. So this is the IPv6 RPKI table, all right? This is the information that you have for the various tables, the IPv4 table and the IPv6 table. Now let's take a specific prefix to view the status from there, from this table. So if I take, what prefix should we take? So I have prefix, I'll take one prefix actually from, let's say Rwanda 102.23.0.0. This is /18. What do we get? Oops. Show BGP, no, it's IPv6. IPv4. So look at the status, the RPKI status of this prefix. This prefix here, if you look at RPKI, it's gonna specify the RPKI. So this is a valid. This is a valid RPKI. So it has a RUA. This prefix actually has a RUA, and the RUA is for this ASN, right? The ASN 2912. All right. So let's take an example, another example of prefix. This time I'm gonna take.
Stefan?
Yeah. Yes.
At one point, also check on the chat. There is some statement that needs your validation. But
okay,
just finish this and then go to the chat too.
All right, thank you. So if I take prefix 59.144.0/24, what do I get here? I get, oh, this has become valid. At some point in time, this was invalid. This was an invalid prefix. What if I do this? If I do 25, what do we get? It's not in the table. It's not in the network table. Let me take another prefix. That is, if I take 41, this is actually a prefix in Rwanda, 138.81.0/21. What do we get? Guess what? We get a not found. Obvious, right? Because there are a lot of networks actually right now in Rwanda that are not yet on Rpki. So it is high time for us to start creating our ROAS, because look at, if I configure my network and I want to do Rpki validation, this prefix, I might drop it. If I'm very strict, if I'm paranoid, I'm going to drop this prefix. Meanwhile, it's a valid prefix. You just need to take like 15 minutes to go on the my Afnic portal and create your ROAS. So that is it for me. That's what I had for you for today. What else can I share? So yeah, so for the implementations, because there are some software who will not support Rpki. So for the Cisco, you don't have a Cisco from 15.2, it is not going to support Rpki, so you need to upgrade your software. All the Cisco XRs, they will support from 4.3, Juniper from 12, Nokia, Huawei, FRR, Birds, Open BGP, and so on. So that is it. So if you want to see implementation of this, there are also some YouTube videos that we created for you, which you can go and look. And that is it. I will stop here and see if there are questions. I'll first look in the chat. So Eddie was saying, before one has configured any of those who are, the network will always appear as unknown. Yes, exactly. And you saw the example of the prefix that I took from the 41.138.81.0/21. It is unknown because no RUA is being created. So it will appear there as unknown. Okay. Do we not risk dropping legitimate traffic by dropping all invalids? No. Invalid, if is invalid, it means that there is an attempt of hijack. The only legitimate traffic that you can drop is when you drop unknowns. Unknowns are legitimate traffic, could be legitimate traffic because those networks have not yet created their ROAS in the system. But when it is invalid, when the BGP says it's invalid, it means that this is an attempt to hijack.
Yeah, go ahead.
Yeah, go ahead.
Or you made a mistake in configuring it.
Yeah, or you made a mistake, yeah.
So because this is whenever you try to configure firewall, I think experience say that when you start to configure a firewall, you always find the day where you lock yourself out of your own firewall. So
yeah,
if you make a mistake configuring it, let's say even the prefix length, and then when you go you route a different prefix length, that on prefix length of yours will appear as invalid, right?
Yeah, it will appear as invalid. And we have no magic to know that you are the one doing this mistake, right? Yeah.
Yeah. So the only legitimate would be a mistake of the network manager. And but again, that's the way I understood. Not found is maybe, but when it is invalid, that means someone took the pain to tell the world how they are going to be visible to the world. And then someone else came and told the world a different way than the one you defined at the beginning. And when such a thing happens, most likely it's a fake news. So you really want people not to go on fake news and accept this invalid. So accepting an invalid is being too permissive, actually.
Yeah.
Okay, so I'm becoming an expert. Thank you.
All right. So yeah. So any other question? The floor is open.
Now I have a question on the. I don't think it's a question, but in terms of hackathon, is it hackathon? Not hackathon. Deployathon. Okay. What are the services that we provide to hold our members' hand as they deploy this? Let it be deployathon or let it be help desk.
So in terms of support, we have many avenues. Any organization right now can contact Afrinic and pose their problem. We will have them in a one-to-one session. We help them throughout the deployment. We will audit their network and tell them exactly what they need to deploy and help them to do that deployment. Another scenario is when we organize deployathons. We organize deployathons, we invite network operators throughout the continent, and deployathons actually go for 3 to 4 days, whereby we go step by step in the deployment process. It could be IPv6 deployment, it could be creating your ROAS, it could be configuring this route origin verification on your network. So we have all of those formats. And actually, Rita or Ines can reach out to us, say we want this for the network operators in Rwanda, then we are going to organize something for them and help them to do the configurations. We are very open, we are available because our mission is to have a strong internet for Africa. Okay. Any other question? Hello? Oops.
There is a question in the chat, Stefan.
The deployment can take how long? All right. So the deployment depends on your specific case. There are some cases where we get to the organization, you have problems to connect to the portal, we need to reset the passwords and things like that. There are some situations where we get to an organization, you are not even in good standing, we have to settle all of that before we continue. There are some situations where we get and like the equipment that you are using is obsolete, we need to sort out that. So it depends, it depends on the organization. There are some, if we can, so if we say we want to secure your network, actually you saw it, it will take us like 15 minutes to do this, to create your ROAS on the portal, 15 to 30 minutes or 1 hour maximum to create your ROAS on the system. Now the next step is to configure on your router. Configuring this on your router, it takes less than an hour. So within 2 hours, doing this Rpki, you can have it on your network. Now, if you have other problems like IPv6 deployment and things like that, that will also depend on your situation, the situation of your network. We go in some networks where the upstream provider is not, your link is not activated. You will need to write to the upstream providers. Sometimes there are some upstream providers that are not really responsive. They will take their time to respond, and so it's a case on case. In terms of requirements, I suppose the validator runs on a server within my network. What specs should this have? So it's a very, very, very tiny machine, like a machine with 20 gig of disk space, 4 gig of RAM will actually run a validator. 4 gig is even like very much. Any of those validators, like the Rpki, the Routinator. The most famous one right now is Routinator, and it takes like it's very easy to set up. We have implemented ROAS with IPv6. We need your support with IPv4. Sure. So reach out to Grace and she will arrange and we can support. Please take a few minutes to fill, the feedback form, please take a few minutes to fill it. So that is it. If there are not other questions, I will give the floor back to Grace to conclude.
Thank you, Steve. Grace is offline, so I will take over. Thank you for your time to avail this webinar. It was from myself, who is not a technical person. I was enjoying, and I want to take this opportunity to thank you so very much for preparing this presentation and for our community. I'm sure they have enjoyed, and that's why we have asked them to fill the form so that next time we know which they want us to organize for them. So thank you, Musa, for making this so great. And we want to appreciate Afrinic for inviting you to speak to our community. Thank you, Eddie, for also honoring us and be part of the webinar, to contribute, and also to build the internet community of Rwanda. And those also who attended from other regions, thank you for being part of us. We want to really thank you so very much. If there is any other question in the chat or in the team, then we can close our webinar. But before closing, as we have Eddie here from Afrinic, and maybe if you have just a short message for the community for African region, you may take over. Thank you.
Thank you, Geoffrey. I really like what I'm seeing here. I looked at the names and I realized that it's not only names from Rwanda, and I understand that you also invited other people from other places. This is the spirit of what we want to do. And as for us as Afrinic, we really need to reach as many places as possible with this message. As you could see, it is a 2 hour or half a day changes. Of course, for you to plan it, it takes some time, but it's not that complex, and you can go step by step, and we are there to support. So I really put this challenge in each one of you. If you already have your own resources, let's do our best to reduce the number of unfound that Africa is showing to the world. And we cannot do it alone, but we need you to do that. And together, I think we are going to get there. Thank you so much, and wish you a pleasant evening.
Bye-bye, everyone.
Yeah, thank you, Eddie. Thank you, Musa. And thank you, all of you, for attending. Have a great weekend ahead. Thank you.
Thank you. Goodbye.
Bye.